In this video, we will introduce what the quotient rule is and do some examples. So the rule says if f and g are differentiable functions, then the derivative of f of x over g of x. So when I divide two functions, this is called a quotient. That's why it's the quotient rule. The quotient rule says, okay, this derivative is going to be the bottom function times the derivative of the top, and then minus the top function, f of x, times the derivative of the bottom. Okay, so far it's looking kind of close to the product rule, but then this is going to be all over that denominator squared. So just like with the product rule, I'm going to give you a memory trick that helps to remember what the quotient rule is saying. So the memory trick I have is, if I take the derivative of, and I like to call the top function high and the bottom function low. So the derivative of high over low, a fractional thing like this, is going to be low d high, which I'll write as d, and then high, which means the derivative of the top, and then minus high d low, which means the derivative of the bottom function. So low d high means the bottom function times the derivative of the top function, or low times the derivative of the high function. And then all over low squared. So just like with the product rule memory trick, I'm going to have us pause for a quick 30 seconds. Maybe it was 15 seconds before, and just chant this memory trick a couple of times. So I'm going to do it together, or I'm going to do it just by myself here in the video a couple of times. So the derivative of high over low is low d high minus high d low over low squared. One more time. It's low d high minus high d low over low squared. Pause it for another 10 seconds or so and just chant that a couple of times on your own. Alrighty, so hopefully you did that, and let's do an example now. So this example has this function f of x, which is 1 minus 1 over x squared, all over 4x cubed plus x plus 2. And I want to find the equation of the tangent line to this function at 1 comma f of 1. All right, so when a question asks me to find an equation of a tangent line, for the equation of any line, I'm going to need the slope, and I'm going to need a point. We could also try for slope and y-intercept. Just usually in practice, we're rarely just given the y-intercept. So usually it's going to be more efficient to use point slope form. So that's what I'll do. Okay, so for the point, it tells me the point that I want the tangent line to be at. The x-coordinate's 1. Okay, and the y-coordinate is f of 1. So let's work out what f of 1 is. If I plug 1 into this function, I'll get 1 minus 1 over 1 on the top. Over, on the bottom, we get 4 plus 1 plus 2, which is 0 over 7, which simplifies to just 0. Okay, so the x-coordinate of my point is 1, and the y-coordinate of my point is 0. So the x-coordinate is 1, and the y-coordinate is 0. All right, so now I need the slope. For the slope of the tangent line, remember the derivative tells me that. So I need to find the derivative at, in this case, x equals 1. Okay, so to get that, let's first find the derivative function. So let's first get f prime of x. And I have a function on top and a function on the bottom, so this is where quotient rule is going to come in handy. So if I use the quotient rule, it says, okay, my derivative, let me give myself a little bit more room here. My derivative is going to be, so low d high, low is 4x cubed plus x plus 2. That is low. And then let's do d high. So d high, so derivative of the top, 1 minus. And it's going to be helpful to rewrite 1 over x squared as x to the negative 2. So that is low d high. So low d high. And then I'm going to need minus high d low. So let's write that next. So minus high, which is 1 minus x to the negative 2. And then d low, so that's going to be the derivative of the bottom, the derivative of 4x cubed plus x plus 2. This whole thing goes over low squared. All over low squared. So that is 4x to the third plus x plus 2, that being squared. All right, let's evaluate these derivatives. We have f prime of x equals 4x to the third plus x plus 2. And then the derivative of 1 is 0 because it's constant. And for the next term, I use power rule. The negative 2 comes down to give me a plus 2. And then I get x to the negative 3 when I subtract 1 from the power. All right, and then minus 1 minus x to the negative 2. And for this next derivative, it's just a bunch of quick ones. 4x to the third, that derivative is 12x squared, and derivative of x is 1. The derivative of 2 is 0 because it's constant. All right, so we have this all over the denominator squared, all over 4x to the third plus x plus 2 being squared. All right, so we need to plug 1 into this to get the slope of the tangent line when x equals 1. So if we plug 1 in, we'll get 4 plus 1 plus 2 first. And then times, so 2x to the negative third, that's going to be, if I plug 1 into that, 1 to the negative third, 1 to any power is just 1. So I'll get 2 times 1, which is 2. And then I get minus, let's see, this will be 1 minus, 1 to any power is still 1, so 1 minus 1. And then times, this will be 12 plus 1. And on the bottom, I'll get 4 plus 1 plus 2 squared. All right. So the nice thing is that 1 minus 1 is 0. And 0 times anything is just going to be 0. So what we're left with, 4 plus 1 plus 2, that's 7. We get 7 times 2 on the top, which is 14. On the bottom, we get 7 squared, which is 49. It might have been quicker to realize, oh, that there's a 7 on top and a 7 squared on the bottom, and I could cancel a 7. But let's say I didn't realize that. Now I could simplify this fraction. I could divide the top and the bottom by 7 to get 2 on the top and a 7 on the bottom, so I can still work it out. So that is my slope of my tangent line. So we got the slope, 2 over 7. We got the point, 1 comma 0. So we're ready to write down the equation. Okay, so we get ready for this equation in point slope form. We need y minus the y coordinate, which was 0, equals m, 2 over 7, times x minus the x coordinate, which was 1. And that's my equation. Totally fine to leave it in point slope form. But if I did want to simplify it, I just got to put it in y equals mx plus b form. I just have to distribute 2 over 7. Because y minus 0 is just y. I get y equals 2 sevenths x minus 2 over 7. Okay, so either way, either of these are the equation of our line, just in different forms. All right, so let's end with a final example. All right, so I have this function g of z, which is z to the third plus 4 over z squared times e to the z. And I want to find g prime of z, my derivative. For this one, I want you to pause the video for 3 minutes to try this one on your own. It's going to be really good practice with reviewing our quotient and product rules. 4, 3, 2, 1, pause it and try it for 3 minutes. All right, so hopefully you've done that. Hopefully paused it for about 3 minutes to try this. So I see a function on top, I see this function on the bottom. That's making me think quotient rule. So when I write my derivative, if I do quotient rule, we'll get low d high first. So low is z squared e to the z, and then times d high. So times the derivative of z to the 3 plus 4 minus high d low. So minus high z to the 3 plus 4 d low. So times the derivative of the bottom, z squared e to the z. And then over low squared. So this is going to be over low. This is low, z squared e to the z. That thing being squared. Okay, so what's left to do is for me to figure out these derivatives on the top. All right, so let's start to work those out. I got z squared e to the z, and then times that derivative. Derivative z cubed is 3z squared. Derivative 4 is 0, because it's constant. And then minus z to the 3 plus 4. And then times the derivative of z squared e to the z. But for this derivative, we are going to need, these are two functions multiplying each other. I'm going to need product rule. There's no way to simplify that to avoid product rule. So I'm going to need product rule for this. So let's put a big old bracket, and start to write down what we get from product rule. So from product rule, we're going to get the first function, which is z squared, times the derivative of the second. And as we get more comfortable with these product and quotient rule questions, I won't always like write ddz of whatever it is I need to take the derivative of. I'll just sort of do it in one step. I'm going to start to practice that here. When I do the derivative of the second function, e to the z, that is just going to be e to the z. So that is the derivative of the second. All right, and then I have plus the second, which is e to the z, and then times the derivative of the first, derivative of z squared, which will be 2z. And I close that bracket. And this whole thing over low squared, all over z squared e to the z, that quantity being squared. And at this point, I've finished my derivative. So that is g prime of z. So let's box that. And that's our answer. In terms of our goals, we finished our last goal for this section already. We've talked about when and how we can apply the quotient rule. So this was a very short section. I don't expect you to have the product rule and quotient rule totally down after this, because we covered this content quickly. What's going to happen is, as we introduce new derivative rules, like next we'll talk about how to do derivatives of trig functions. After we learn that, we'll start to put those in product and quotient rule questions. So we'll continue to get practice with these. Later, we'll talk about how to do derivatives of log functions and other exponential functions. And then we'll see those in product and quotient rule situations. So we'll continue to get practice with these virtually throughout the rest of the course.